In section 2.5, we look at the distributive property, and this is going to be something you'll use throughout the year, so make sure you get this down well. So the distributive property looks like this. If you have A, B, and C are all real numbers, if you take A times parentheses B plus C, we can distribute that A by multiplying A times each term inside the parentheses separately. So we're going to take A times B plus A times C. And it's very common that people will get the first part, A times B, and forget the second part, A times C. Don't do that. So for example, if we have 2 times 8 plus 5, we can take 2 times 8 plus 2 times 5. You can also have the multiplication after the parentheses. It's still the same idea. We're still going to distribute the A times the 2 terms inside. So A times B, and then A times C. So it just looks a little bit different. Remember that multiplication is commutative, so BA is the same thing as A times B. So for example, if we have 7 plus 2 in parentheses times 3, we can take 7 times the 3 plus 2 times the 3. If we have a subtraction inside, be careful with signs here. So if we take A times B minus C in parentheses, we still have the A being distributed. We just have to be careful that there's a subtraction here. So for example, if we take 6 times parentheses 10 minus 3, we'll take 6 times 10 minus 6 times 3. So a little more terminology here. We're going to have terms which are parts of an expression that are added together. And so in other words, terms are separated by operations, which will be addition, or remember that subtraction is the same thing as adding a negative. A coefficient is a number part of a term that has a variable. So for example, if you see the term 3x, 3 is the coefficient here. X is the variable part, 3 is the coefficient. That's what we're multiplying times the variable. Constant term is a number part that has no variable part. So for example, 3. Like terms are terms that have the same variable parts, in other words, the same variables and the same exponents. So for example, if you had 4x squared plus 3x squared, those are like terms. On the other hand, 4x squared plus 3x are not like terms because you have different variables. Same variable but different exponents. Here we have x to the second power, here we have x to the first power. Those are not like terms. And this is going to be important when it comes to combining like terms. So here we have negative 2x plus 5 plus x plus 3 plus negative x. So we have 5 different terms all being separated by addition. We have coefficients wherever there is an x. So here we have negative 2 as a coefficient. X by itself means 1x, so our coefficient there is 1. And negative x means negative 1x. So we have coefficients of negative 2, 1, and negative 1. Constants are 5 and 3. And then the like terms would be negative 2x, x, and negative x are like terms. And 5 and 3 are also like terms because they're constants. Then equivalent expressions are 2 expressions that have the same value for all values of the variable. So for example, actually we'll see an example of this later. So we'll save that. And here we have identify the terms, like terms, coefficients, and constant terms of the expression 4x plus 6 minus 2x minus 3. So the terms are the items, we have either a number or a variable, or a number and a variable combined with multiplication, or it could be division. But here we have 4x is our first term, and then terms are separated by addition or subtraction. Second term is 6. Third term is a negative 2x. Don't forget that the subtraction means a negative 2x and then negative 3 for the last term. Like terms, we have 4x and negative 2x. Those are like terms. Also, we have our constants, 6 and negative 3. So those are like terms. Coefficients are 4 and negative 2. So those are being multiplied by x. And then the constant terms are 6 and negative 3. Okay, same idea here. Identify the terms, like terms, coefficients, and constant terms of the expression 2x plus 5 minus x squared minus 8. So terms are 2x, 5, negative x squared, and negative 8. Like terms, we don't have any like terms with x in them because the exponents are different. X to the first, x squared, those are not like terms. We do have our constants though. So 5 and negative 8. Oops, so I'll write 5 and negative 8. We want to pair those up. The coefficients are 2 and negative 1. Negative x squared means negative 1 times x squared. And then the constant terms are 5 and negative 8. Okay, use the distributive property to write an equivalent expression. So in other words, we're not solving for anything, we're just writing this in a different form. So distribute the 4 times x and then times 3. So that's going to be equal to 4x plus 12. Okay, negative 2x and then negative 2 times a positive 6 will give us negative 2x, and then negative 2 times 12 is negative 12, so negative 2x minus 12. We're going to distribute negative 3 here, so we have negative 3 times x is negative 3x, and negative 3 times a negative 2 is a positive 6. So we have 3x plus 6. Here we have a negative 1. Negative 1 times negative x and a negative 1 times 7. So we get a positive x and a negative 7. And notice, by the way, this is something we'll use later in the year, much later, but this is a neat little trick sometimes to distribute a negative 1. It will change the sign of all of the terms within the parentheses. So a negative became a positive, positive became a negative. And then 1/2 times 6 and 1/2 times negative 10y. 1/2 times 6, you can either think of that as what is half of 6 or 6 divided by 2. Either way, that's 3. And then 1/2 times negative 10y is negative 5y. So focus on the coefficient, 1/2 times negative 10, and then attach the y. 3m times negative 2m. Well, first of all, coefficients. 3 times negative 2 will give us negative 6. M times m will give us m squared. And then 3m times 5 is 15m. So the 3 times 5 is where we get our 15, and then we still have times m. Okay, simplify the expression. So here we're going to apply the distributive property and then look and see if we can combine any like terms. So this is equal to 2 times n, 2 times 4 will give us 2n plus 8 plus, and then 3 times n, 3 times 6, so 3n plus 18. Then we look for like terms. 2n and 3n will give us like terms, so those will add to 5n. And then our constants can add together. 8 plus 18 will give us 26, and that's as far as we can go. Negative 2 times t minus 4 will give us negative 2t plus 8. So negative 2 times negative 4 is plus 8, minus 6 times 2t would give us 12t, and then 6 times 2 will give us 12. We're still subtracting though. You can think of that as a negative 6 times 2 would give us negative 12. Now look for like terms. We have negative 2t minus 12t gives us negative 14t. And then for the constants, 8 minus 12 will give us negative 4. Hey, 4 times x minus 3. Here we can take this and get 4x minus 12 plus 3x minus 9 and combine like terms. And that will give us 4x plus 3x is 7x. Negative 12 minus 9 is negative 21. So 7x minus 21. There is another little trick we could have used. Notice that x minus 3 shows up both times. So we could actually distribute here or group a little bit differently and say that this is equal to 4 plus 3 times x minus 3, or in other words 7 times x minus 3, which is still going to give us 7x minus 21. So either way. Hey, Sarah works out 40 minutes every day lifting weights and or riding an exercise bike. She burns 8 calories per minute lifting weights and 10 calories per minute riding the exercise bike. Let W represent the number of minutes she lifts weights, so W for weights, on a given day. Find the number of calories she burns in her 40-minute workout if she lifts weights for 15 minutes. So here we have the burn rate, so calories burned will be the burn rate lifting weights, which we were told is 8 calories per minute. So 8 calories per minute times the time that she spent lifting weights, which is going to be 15 minutes. Plus the burn rate riding an exercise bike, which is 10 calories per minute, times, and we're going to take 40 minus W. So in other words, 40 minus 15 minutes. Okay, so however long she spent lifting weights, she spends 40 minus that time riding the exercise bike to get a total of 40 minutes. So if we multiply this out, notice that our units cancel for minutes in both cases, and we're going to want to simplify that. So this is 8 calories times 15 will give us 120 calories plus, and we can write this out, 10 calories times 40 minus 15 will give us 25. So she spent 25 minutes riding the exercise bike. So that's 120 calories plus 10 times 25 will give us 250 calories for a total of 370 calories. Alright, so there you go with the distributive property. Again, this is going to be very important throughout the year, so make sure you get this section down very solidly. Good luck.